So, one of our freezers has decided to go faulty. When it tries to go into the defrost sort of mode, I don't know if you can hear there. There you can see the front panel sort of like light up. It tries to kick in the fan and then it resets itself. And also I think the controls here aren't actually doing anything now either. So I think there's a problem with this control board here. So I think we'll get it out. We'll get it on the blue mat and we'll have a look at it and see if we can repair it. So I've removed the front panel from the freezer. And it looks like we've got a smaller circuit board that's held on by 2 screws. So let's flip that round. And we'll take those screws out and see if we can get this board out. It looks like it's a little module thing there. Let's see if we can get this apart. I see some clips there. And maybe another one. Right, let's zoom down a bit. So it looks like we've got a small microcontroller there. I'll see if I can get this board out so we can get a bit of a better look at it. Right, so it looks like we've got a small microcontroller there. I'm not sure what the number is of it. Let's see if I can see. MCHC 908. I've not heard of one of those before. Well, I can't see anything blown as such. We've got a few capacitors there. Let's see if we can work out what's going on. F1 and F2, I think that could be the fan. Because it looks like we've got some kind of, looks like a triac there. Looks like we've got a relay. That could be for turning the heater on and off for the frost free, or for turning the compressor on and off maybe, I don't know. So I'm not sure where it measures its temperature from. Right, so it looks like the power comes in, I would say, on this resistor here. Unless it goes to that capacitor first, hold on. Right, okay, yeah. Right, so the power looks like it comes in on this resistor. Goes through this capacitor here, which I guess is being used as like a capacitive dropper. I've got a bridge rectifier here, and then a few capacitors here. Now, I have had a similar problem to something like this on a central heating control system before, and it turned out to be the capacitive dropper had like deteriorated over time, so it wasn't at the right capacitance. So I wonder if it's worth taking that out and testing it. Right, I think I'll try that first, and then we'll look at the other capacitors, because I think it's a capacitor problem by the way that the light sort of dims as it's trying to kick in the relay. I think it's obviously something on the power supply side. So right, let's get this capacitor out. I'm just going to apply a bit of solder to it first. And we should just be able to pull it out, I think. Oh, there's a little bit of a struggle to get out. So it looks like a 1 microfarad capacitor, I think that is. Anyway, let's check what we should have done first, just in case it's got any power in it. Well, that's only measuring 223 nanofarads. And it's supposed to be a 1 microfarad. So I think that could be the problem. I'll just double check. Yeah, that doesn't seem right. Right, I'll see if I can acquire one of those and then I'll be back. Right, I've got a new capacitor and we'll just compare it to the old one. So this is the old one, as you can see, 224 nanofarads, and this is the new one, which is 105 microfarads. So yeah, so that's definitely faulty, so I'll get that out of the way. But what I'm going to do, I'm going to check these capacitors here, but I think I'll just check them in circuit. It should give you a rough idea. Now there's two of them, 470 microfarads, and there's another one here of 220. So we'll just try the 221 first. Yeah, that's probably about right, 212. What was these ones again? 470. So we'll just check these. Yeah, so we're getting about 800 microfarads on there, but I've got a feeling that both of these are connected together. Yeah. So I would say that's probably about right as well. Right, so I'm going to clean up these holes and we'll pop this new capacitor in, and then we'll give it a test, and hopefully that's a nice simple and easy repair. I was going to give it a little clean up with IPA, but yeah, I'm not really that bothered. Trying to get it back together though, that might be a different matter. One of the LEDs is not quite in the place. Right, there we go. Right, we'll connect it back up and see if it works. Right, so I've got it installed back in the unit. We'll just power it on. And we've got a power light, so that seems a good sign. Let's see if it does anything now. Yes. That seems to work. Okay, let's try this super button now, see if that does anything. Yeah. Yeah, so I see that's working now then. Excellent, another little job repaired. A pair of ELGER Nightguard lights. Now these are kind of rechargeable. I think they're like a wireless charger here, and a rechargeable type torch which does motion detection, and I think one of them's got a switch on the side like dusk till dawn. So is it this one? Yeah, it's got a dusk till dawn. Now, both of these units don't work, and I volunteer at the local repair cafe, and somebody brought these in and asked could we have a look at them, and I thought it might make an interesting repair video. So I'll just get one out of the way and let's have a look at one. Now, he did say that the charger was the problem because he's tried the lights on a different charger and the lights seem to work okay, so it seems to be a problem with the charger. So let's see if we can pop these, I'll tell you what, we'll just try them first. Put some power here. Just a double check. Well, it's making a rather strange noise in there, which didn't sound too good. Right. So I'd say the fuse is intact. Right, let's pop these little rubber grommet things out. It looks like we've got 4 screws. Right, and it looks like we've got a small circuit board inside. Right, and a load of capacitors. Right. Tell you what, we'll zoom down a bit. Let's see if there's any voltage in any of these capacitors before we start touching it. Oh, 70 volts in that one still. And there's another capacitor here, a 400 volt one, so we'll check that. Yeah, that's still got about 60 or 50 volts in it. Right, so we'll just let that discharge a minute and then we'll come back to it. Right, it's been a minute or so now. And let's see, that's safe to work on now. Right, let's see if we can see. Oh, well, I can see something straight away. Actually, I can see a couple of things. Let's just zoom down a bit. Right, so the first thing I've noticed is there's a resistor which seems to be burned out here, and also that capacitor there, if you notice how it's domed at the top there, and it looks like it's actually split. So I would say that capacitor has blown, it's overheated, and it could have caused that resistor to fail if it hasn't been getting a smoothed output. It looks like there's a built-in fuse on the circuit board as well, so we'll check that. And it looks like there's just one transistor, and that must be the coil for the output of the wireless charging. So I think what I'll do, I'll check that this fuse here just to see if that's intact, and then we'll check this transistor here, and then we'll see if we can work out what parts are required to repair it. Right, zoom out a bit so you can see the meter. Right, let's see if this fuse measures okay. Yep, so the fuse is intact, so that's okay. Let's check this transistor now. Now we should get 2 readings of about 0.5 or so on 2 of the legs. Right, so that's one of them, and that's the other one. So this one at the left hand side seems to be the base, because from the base you should get about a 0.6 reading between the base and the collector, and about the same between the base and the emitter. And you shouldn't get anything between the collector and the emitter. So yeah, that's that seems okay. So the transistor seems alright, so I think the problem is this capacitor and this resistor. Let's just see what this resistor measures. And pretty much nothing. Right, I'm going to take that resistor out and remove this capacitor, and then we'll test them out of circuit. I'm not going to test the capacitor because I can see it's gone in anyway, so... Right, we'll get a bit of solder wick. And we'll use a bit of flux. We'll just put a bit of flux on here first. Right, so that's the capacitor removed, and the resistor is just across here. I might actually reverse engineer this circuit so we can actually see what's going on and how it works. Right, let's put a bit of flux on these couple of pins. Right, see if we can get this resistor out. Right, so yeah, so that resistor's open circuit. Let's just measure this capacitor, just out of curiosity. And it's here 4.7, or supposed to be 4.7. And it's only measuring about 2.5, between 2.9 and 2.5. So, right, I'm going to try and reverse engineer this circuit, and hopefully I'll figure out how it works. The reverse engineering is complete. Now, I'm not an expert in electronic engineering, so hopefully I've got this right. So what it seems that happens is the main comes in on these two wires here. It goes through a fuse. We've got a bit filter in here. We've got a 1 meg ohm resistor with a 470 nanofarad capacitor across there. Then it goes through here, which is a 560 and a 1 meg again, but this time it goes through in series. And I think this is to do with current limiting. Then goes through these 4 diodes here, which form a bridge rectifier. So that'll take the AC coming in, change it to DC, and that's when we end up on that capacitor, which was blown here, this 400 4.7. So the positive then goes to the coil, which feeds which is for the wireless charging, which is just here. So positive goes to the coil. The negative side then goes through another bit filter in here, through a capacitor at the bottom, and also to the coil. Now, what happens is, when the voltage increases, it looks like it goes through this resistor to the base of this transistor. So once the voltage reaches a certain voltage, this transistor switches on, and it effectively bypasses this capacitor. So it effectively links the negative through the transistor here to the coil, which is also connected to the positive. So it charges up that coil when that switches on. And what happens is the power from this capacitor gets dumped into that coil, and it charges that coil up. So as it does that, the voltage here drops, that transistor then switches off, and then the power that's, or the electromagnetic energy that's built up in this coil, flows down here and into this capacitor, charging up this capacitor. And it eventually flows back and forward through this coil, and that's called an LC oscillator, and it produces a sort of waveform like this, which slowly decreases. But before it gets to a certain point, it'll kick in again, and so you'll just get a constant oscillation like that. Now, this burnt out resistor, I've actually made a mistake on my diagram here, because this is the resistor of the unknown value, and that capacitor there is actually at 220, not 470. Yeah, so the power, like I said, comes through here when that transistor switches on, through this resistor into that capacitor, and that's when it starts oscillating. So we need to find out the value of this resistor here. Now, I did have a quick look online, and I did find a forum, and it did have the value of that capacitor on as I think it was 2.4k. So I'll bring a link up to the forum and the picture that I found of the insides of one of these units that wasn't blown up. Now I haven't got a 2.4K, but I have got a 2.2 and I have got a 200 ohm resistor, or 220 ohm. So what I've done is I've soldered both of them together like that, and that should give what the required 2.4K. And I should have some capacitors that I've ordered as well. So hopefully we should be able to get this back up and running. Let's move this out of the way for now. It's a slightly bigger footprint, this capacitor, so hopefully we can still get the lid back on. And it looks like one of the wires has came off. Right, let's see if we can figure out where that goes. I'll just tin it. And it looks like it goes here. Right, so let's see if this wants to go back together now. I don't like the idea of the sticky pad thing though. Yeah, it doesn't seem to want to go together properly, this. Right, there's a plastic clip. I think somebody's been into this before, because it looks like there's a plastic clip that this bottom base clips into. That's why it's not going back together properly. Might put some hot glue or something on that, try and hold it together properly. Right, let's see if it goes bang. Yes. Right, I'd say a success. We just need to figure out how to glue it back together now. I think I'm going to put the glue gun on and put some hot glue down here, and then we'll just squeeze that in like that, and I think that should do. So like I said, there's a clip broken off on there. So while I'm waiting for the glue gun to heat up, I thought I'd just take it apart again, just to have a quick look. And they've actually used glue gun to hold the hot glue to hold the wires in place. So what I'm thinking is I'm going to put some hot glue around the bottom of the unit here, and where this little stud's broken, and hopefully that should hold it all together, and then we'll put the screws in. Right, I think that's got a hold of it. Let's get the rest of the screws back in. Right, let's check it still works. Yes. Right, it's one done. Right, let's have a look at the other one then. And it looks like somebody's already been into this one, because there's only one of the grommets left, should I say. Yeah, it looks like the plastic's bent there, where somebody's tried to prise it apart. And again, this looks the same sort of thing. I'll just zoom down a bit. This looks like the same sort of thing as the previous light. We've got the same resistor burned out here. The capacitor doesn't look as bad, but it's still slightly bulged at the top, so I would think it's just going to be a matter of changing that capacitor again and changing that resistor. Oh, a bit of a broken plastic clip in here. Yeah, so those two holes clear, and that resistor's just there. Right, I have another resistor that I prepared earlier, so we shall pop that in. And we need a new capacitor. And we must make sure that we get this around the right way, otherwise it'll be a very loud bang. So I guess this is a fairly common problem with these lights. Alright, two little holes that the circuit board fits into, like that. Right. I think I'm going to put some hot glue around the bottom of this unit as well, seeing as the clip that's supposed to hold it together is broken off. And that was already done because I didn't do it. Well, we'll pop the one little grommet thing back in that's with it. And then we'll give this one a try. And hopefully this one doesn't go bang. Yes. There we go then, both working. Right, so 2 repairs in 1 video. Well, if you enjoyed this video, please give it the thumbs up. If you want to see more like it, please subscribe. Any comments or questions, please leave it in the comment section below. And as always, have a great day. Thanks for watching.